learning objective for this lesson is to determine the products of displacement reactions. So a displacement reaction occurs when a more reactive metal displaces a less reactive metal. In other words, it moves it along and takes its place in the compound. So the way I like to think about this is the more reactive metals being kind of like a bully to the less reactive metals, and kind of just comes in and says, hey, I like the look of your compound, get out of here, I'm going to take over your compound. And that's essentially what he does. It knocks it out and takes over its compound. So our general equation is going to look like this. You have your more reactive metal and your less reactive metal compound will give us that less reactive metal by itself, and then the more reactive metal taken over with that compound. So an example here would be aluminium and lead nitrate. Aluminium is a more reactive metal than lead, so it takes over the nitrate and becomes aluminium nitrate and lead. Now, another question you're asking here is, how do we know which one's more reactive? This comes down to a thing we call the reactivity series. And all that is a list of all the metals in their order of reactivities. So here it is here, you can see with potassium being right at the top, with platinum, gold and silver being down the bottom, those ones that we call the least reactive. So what I'm going to do now is just a quick little demo using the chemicals and materials and metals that I have available. I'm going to use magnesium and copper sulfate. Now what we should be able to do is make a prediction based on the reactivity series of whether a reaction is going to occur or not. So we can see that magnesium is quite high up there on our reactivity series, and copper is right down the bottom. So we should be able to determine that that magnesium is going to bully the copper, more reactive, it's going to push it out of that sulfate and undergo a chemical reaction. So let's go have a look. Okay, so I'm going to load in some copper sulfate into this one. You can see, as most copper compounds do, this one's got that little bluey tinge to it. Okay, now we're looking for signs of a reaction, and as you can see, this one's fizzing up there. You can see that fizzing. So that gas being produced is indicative of a chemical reaction occurring, which in this case is a displacement reaction. So from that reaction that we saw, we can determine that a displacement reaction occurred. So we can say that the products were copper and magnesium sulfate. Now, as you can see, essentially all I've done in this equation is switch the copper and the magnesium around. Now what you've got to be very careful of down the track if you have to do one of these equations is you have to ensure that or to check those valencies to make sure that they're not just going to be a nice easy swap. You may need to change the equation slightly, or the amount of sulfates, or the amount of metals in the compound. So just be sure to check that those valencies all add up.